minus q charge, this is plus q charge, and this is separated by some distance. So this is known as the, d is the distance. This is known as the electric dipole. So if you take the example of electric dipole, we have sodium chloride, sodium NaCl, and we know that we can, if this sodium will lose one electron and this chlorine will get one electron. So this Na positive and Cl negative, this Cl negative is the example of electric dipole, in which there is a certain very small distance between a sodium ion and the chloride ion, and also the distance is very small and charge is also equal and opposite. So you can write the example, sodium chloride NaCl.
Okay, sir.
And so this will be like this thing will be like this. Here somewhere will be a sodium ion, and this sodium ion is separated by some very small distance with chloride ion having negative charge, equal positive charge, equal negative charge. And this distance, this separation is approximately, we can say, in angstrom. This distance d, angstrom is the unit of distance. 1 angstrom is equal to 10 to the power 10 meter. So see how small is the distance in angstrom. So this is the electric dipole. Now there is another term that I will use here, electric dipole moment. Electric dipole moment. Electric dipole moment is a vector quantity, and this is represented by P vector, electric dipole moment. And if you have a dipole, having minus q charge, we know that what is dipole? Minus q charge and a plus q charge. And suppose this is the center of dipole. This time I am taking the center of dipole. And if the distance between two charges I am taking as 2a, then the dipole moment, when you will calculate the dipole moment, then you will take the magnitude of either of charge into the distance between two charges, 2a. This is the dipole moment. This is the dipole moment. And I have already told you this is a vector quantity. Dipole moment is a vector quantity. So this is dipole moment is vector. And if you will talk about the direction of this dipole moment is from negative to positive charge, like this. If you have a dipole moment like this, then this is the distance of dipole moment from negative to positive charge. And if we will talk about the unit of dipole, SI unit, then you can calculate unit from here. Unit of charge is coulomb and unit of distance is meter. So coulomb meter is the SI unit of electric dipole.
Yeah.
Now there is very simple question. Two charges is given as, these are two charges, 2 microcoulomb and minus 2 microcoulomb, and these charges are separated by some distance, and the distance is given. We have to find the dipole moment and the direction of dipole moment. So this is very easy question. For the dipole moment, what is the formula? Any of the charge into distance between the charge.
Yes, sir.
Distance between the charge. So any of the charge, first you will take this, you can take any charge.
Okay,
2
sir.
microcoulomb, and one, this is not microcoulomb, this is millicoulomb. 1 millicoulomb is equal to 10 to the power minus 3 coulomb. So this is 2 millicoulomb. We will convert it into the SI unit, that is coulomb, 10 to the power minus 3 into distance between two charges. What is the distance? 6 microcoulomb.
Yes, sir.
And 1 microcoulomb is equal to 10 to the power minus 6. 1 micrometer, 1 microcoulomb or 1 micrometer is equal to 10 to the power 6 meter. And when micro means 10 to the power minus 6, whether it is charge or whether it is distance. So you will put the value here, 6 into 10 to the power minus 6, and you will get the answer 6 to the 12, and you can add the power minus 6 and minus 3, 10 to the power minus 9, and unit of this is coulometer. So this is the answer. And now they are asking for the direction of dipole moment. So I have told you direction of dipole moment is from negative to positive charge. So
Yes, sir.
direction, when you will talk about the direction of dipole moment is from minus 2 microcoulomb charge to 2 microcoulomb charge. So I am showing the direction here. So this will here in this direction, means in this direction, this is the direction of dipole.
Okay, sir.
I am representing dipole moment here in the vector form. It depends upon you whether you are representing the dipole moment in the vector form or the scalar form.
Okay, sir.
Actually, the thing is that vector form and scalar form means that cannot change the physical quantity. Means if you are writing, suppose you have a force, and we know that force is a vector quantity.
Yes.
If you are writing, you can write the magnitude of force or the direction of the force.
Yes, sir.
Okay, so hope you have understood my point.
Yes.
Just note it down, and after that we will move on electric field due to dipole.
Okay, sir.
This is a very easy topic.
So again, it's cool down.
This is the magnitude of dipole moment. If you have a vector, first you will calculate the magnitude and then direction, or you can first calculate direction, or after that you can calculate magnitude. Because for defining the vector, we need magnitude as well as the direction. Should I scroll down now again?
No, sir. Almost.
Okay. And remember one thing, I am supposing this O as a center of dipole.
Okay, sir. So again, it's cool down.
Now after this we will calculate the electric field due to dipole. Electric field due to dipole at different positions. We will calculate the electric field.
Okay, sir.
Yeah.
Finish, sir.
So I am just giving you a little idea what I am going to do now. So just listen carefully what I want to say that. So this is the center, means the distance between this charge and this point O is A, and this point is A. So we will calculate the electric field on the line joining the two charges at a point on the line joining the two charges. Suppose this is a point P. Here we will calculate the electric field due to this dipole. And after that we will calculate the electric field at some point which is the perpendicular bisector. Perpendicular bisector means this, when we draw a perpendicular line on this line joining the two charges, this divides the distance between two charges, means this divides this distance to a equally. So this P point, this point is known as the axial point, or you can say axial line. This position is known as the equatorial. So we will calculate the now electric field at equatorial position and axial position.
Okay.
And Ziyad, one thing I want to tell you, you can calculate the electric field intensity at any point. You can also calculate the electric field at this point also.
Okay, sir.
Yeah. It is not mandatory that you will get. I am doing this because this is the part of your syllabus, and we have to only calculate the electric field at the axial position and equatorial position. If we will calculate here, the calculation will be a little bit difficult, but we can do that.
Okay, sir.
Yeah. If you have a dipole, then you can calculate the position electric field at any position. This is something I am saying general point. General point in space. We have this space and we have an infinite number of points in space. So with respect to the dipole, this is the general point. So this is P, this is Q, and this is R. Now the heading is, write the heading, electric field on the axial line of electric dipole. On the axial line of electric dipole. So just this. Write the heading. Now I will take the dipole and I will mark the axial position. Axial line, I have told you also, this is known as the axial position also. So first what we will take? We will take a dipole first.
Yes, sir.
So I am taking a dipole. Dipole is this. This is dipole. We have two charges, equal and opposite charges, and suppose this is a center of charge, and this, suppose this distance is A and this distance is A, and suppose this is position 1 and this is position 2, and we want to calculate the electric field on the axial line. This is the axial line of the electric dipole. Suppose this is the point P, and at this point P we have to calculate the electric field intensity, or you can say electric field simply. And Ziyad, if you I am having a charge and I want to calculate the electric field at a distance r at this point, and this point is at a distance r. So what is the value of electric field at the point P? What is the formula I have told you? So the formula is, first you will write K constant, Q, you will take this value Q and divided by R square.
Yes, sir.
Okay. So this we will use. So I have told you, if you have forgotten, then so now let's see. This is very simple derivation. You have to just focus on the things that I am telling. Just focus here. You have to calculate the electric field here. So actually we have two charges, one charge and two charge. So what we will do, first we will calculate the electric field at this point due to this charge, and after this we will calculate the electric field due to this charge at a point P, and we will then calculate that electric field at the point P due to both the charges vectorically, and we will get the answer. So this is a positive charge. I am calculating the electric field, and one thing more I want to tell you. Suppose this distance is, you can take this as x. No, you can take this distance as r. This is the center of dipole O. O is the center. O is the center. I am taking a distance r. Suppose this point P is at a distance r from the center of dipole. So due to this charge, the what will be the direction of electric field, Ziyad, at this point P?
Positive, right?
Yeah, this charge is positive, and I want the direction of electric field at this point P. So this is positive charge, na?
Yes, sir.
You are here, so this charge will try to repel a charge. I have told you, where you want to find the direction of electric field, consider there a positive charge.
Okay, yes, sir. Yes.
I have considered here a positive charge. This positive and this positive will repel.
Yes, sir.
And the direction of force is same as that direction of field. So direction of electric field will be in this direction. So this is the electric field due to this charge 2 at 2. This is E2. And now,
Yes, sir.
due to this charge, we will calculate the electric field. Due to this charge, the electric field will be in this direction, because this is negative charge. So this is E1. So now we have calculated the direction of electric field. Now we will calculate E1 and E2, magnitude of electric field. So E1, if I want to calculate the E1, then what is the formula of electric field? First we will write K, then we will write charge. Charge is Q.
Yes, sir.
Now we will take the charge without sign, because we have already considered the direction. Now we are just calculating only magnitude. KQ, and
Plus.
the distance we have to take. So the distance between this point P and this point 1 will be R plus A. This is R plus A, na?
Yes, sir.
You can just focus on this diagram.
Yes,
Then
sir.
then only you will know how this distance are. Suppose this is the point P and this distance is R, you will add this distance. If you want to calculate E2, now
Yes.
what is the expression of E2? Can you tell me? KQ divided by, what will be the distance?
RP.
What will be the distance between this point P and this charge Q?
E1, right?
No.
Distance.
Yeah, I want the distance between this point P and this point 2.
E2,
Just you
right?
can, no. You have to tell the distance in terms of R and this A. We have this A also. Just think about it. No problem. I will tell you otherwise. So see here. First focus on the 2 points where you have to in between. You have to find the distance.
Yes, sir.
Means we know we want this distance. We want this distance, na?
Yes, sir.
So what we will do, this whole distance is R. This
Yes, sir.
whole distance is R. And when we will subtract this R, when we will subtract this A from this R, we will get this distance R minus A.
Yes, sir.
So R minus A square. And this distance means this distance will be R plus A. Between the point P and point 1, where the minus Q charge. So now, if you want to calculate the net electric field at point P, then you have to add the electric field vectorically.
Yes,
So
sir.
I want the net electric field. This is E suffix net electric field at point P. So I will write E2 minus E1.
Yes, sir.
Why I am writing E2 minus E1? Because E2 is greater than E1. E2 is greater than E1 because this charge 2, second charge is nearer to the point P.
Yes, sir.
So the electric field intensity due to this charge is large.
Large.
So what is the value of E2? KQ R minus A square.
Yes, sir.
This is just the simple calculation, nothing else. Simple calculation. KQ divided by R plus A square. Now what we will do, we will take common KQ and we will have 1 upon R minus A square of this minus 1 upon R plus A square of this. Now, Ziyad, this is just the calculation and you can also solve this by yourself, but just I am telling. This is R minus A square, this is R plus A square. So if you will take the LCM of this will become R minus A square multiplied by R plus A square. And after that, we will write here R plus A square minus R minus A. Now we can further calculate this. Now, do you know the formula A plus B square?
Yes, sir.
A
A square minus B. A square plus B square. Yes.
is 2AB. A minus B square is equal to A square plus B square minus 2. Similarly, just I am opening one of the square. I am opening
Yes,
R
sir.
minus A square. So I will write R square plus A square minus 2AR. So I am just opening this square. This will become R square plus A square plus 2AR. Here is minus sign. Open this.
Yes,
R square plus A square minus 2AR. And in denominator, you know this formula. A plus B, A minus B is equal to A square plus
B square.
A
Yes, sir.
square minus B square.
Yes, sir.
A square. So when you will do this, you will write this as this will become. I am just doing this calculation here. So this is R minus A square means you can write this as 2 times and here R plus A and R plus A. So A plus B and A minus B, this will become R square minus A square. Again, this will become R square minus A square. So finally, it will become R square minus A square to the whole square. So r square minus a square to the whole square. Now this r square will cancel this minus r square.
Yes, sir.
This a square will cancel this minus a square, and this is plus
2AR.
2ar, and this is
Yeah.
minus minus plus 2ar.
Yes,
So this
sir.
will become 4ar.
Yes, sir.
4ar, and we have common. We have taken common kq also.
Yes, sir.
Yeah, kq. We have kq into 4ar divided by r square minus a square to the whole square. Okay, just I am modifying this. I am writing it. Can I write this? 2k r q into 2a. Just think about it, because thinking, when you will think, your mind will work properly. When I am just teaching you, and I am just writing the uh, formulas and derivation, and you are not thinking this, just I am not saying that you will do this derivation. I am just saying that just think. So how I have done this? See this.
Sir, did you split 4AR?
Yeah, actually, what I have done. This is KQ now.
Yes, sir.
I have written this 2 into
2 into 2. Yes, sir.
2a into r. I have written,
Okay, sir.
and this is r square minus a square whole square. So what I have done, I have taken this q into 2a
Yes.
out, separate,
Okay. Okay, sir.
and this is 2kr here and q into 2. Because actually you have to make the notes uh, by yourself. If you will make the notes, then it will help you a lot. If you are taking the screenshots, uh, that can also be good. But when you will make your own notes, when you will write by the pen on your copy, then it will gives you another type of feeling. So just and I have told you dipole moment is q into 2a.
Yes,
So
sir.
instead of q into 2a, I can write 2k 2kr p divided by a square. So net electric field at point P is equal to 2kpr divided by r square minus a square to the whole square. So this is the net electric field.
Yes.
And this net electric field we have calculated at the axial position. So this is also written as E axial, E suffix axial is equal to 2kpr divided by r square minus a square to the whole square. So this is the formula of electric field at the axial position. And the direction, if we will calculate the direction of this electric field, direction of E axial. So I have written E2 minus E1, and I have also told you E2 is greater than E1.
Yes.
Then, so the net direction of electric field will be in this direction. This is the direction of E axial.
Okay.
So from negative to positive, and also the direction of dipole is in this direction. Direction of dipole is in this direction. So direction of electric field and direction of dipole movement is same. Same as that of dipole moment, that is from negative to positive charge. Negative to positive charge. Just write it down.
Okay, sir.
So very simple derivation, but you have to just focus, and then you can do this in 2 minutes. Ziyad, you are doing this first time, means this derivation you are doing first time?
Since the revision, sir?
Yeah, this topic, have you already read this topic?
Yes, sir.
Very good. Means just we are revising it again in a better way.
Yes, sir.
So if you have any confusions regarding the direction, regarding the magnitude and everything that you want to ask, that you can ask me. This
Okay, sir.
derivation.
Okay, sir.
Well, when we drive something, when we do the derivation. So basically, in the derivation, 90% is mathematics and 10% is physics.
10%, sir?
Yeah, this is the math, no?
Yes, sir. Yeah.
This is just this formula is from physics, as you can say. But this is, see here, from here to here, this is just math.
Yes, sir.
We are just doing the calculation on there.
Yes, sir.
This is the thing. But calculation is very, very important part. You should know how to calculate the things. You're a maths student, na?
Yes,
Yes.
sir.
So you should be good in the calculation and all that.
Yes, sir.
Yeah.
So you can scroll down.
And also one thing more, make all the distances as I have made properly. Yes?
Okay, sir.
Don't miss any point. Otherwise you may get confused.
So you can scroll down. Finish, sir.
Fine. And I have told you that the distance between two charges of dipole uh, is very small.
Yes, sir.
Is very small. So I will say that in the form of note you can write it. This A na is very less than R. Uh, this A, but when you will see this A is very much less than this R. This
Okay,
R.
sir.
Okay.
Okay.
Practically, when you will see. So what we can do, we can modify this formula. We can modify this formula. As this A is very much less than R. So we can write R square minus A square approximately equal to R square. Okay. We can do this because this A is very small. If you have a number 10 to the power 5, if you have this one, then you can write approximately this as 10 to the power 5.
Yes, sir.
So in this way you can do this. So this formula we can change now. P axial. We can change this formula. This will become 2kpr. In denominator, what we will have? In denominator, what we
2
will have?
minus E square.
This is only r square in denominator. Yeah.
Yes, sir.
Because r square and square of that. Instead of r square minus a square, I will write r square and the
Okay, sir.
square of this square. So
Okay,
this
sir.
is 2kpr divided by r to the power 4 and 1 r is cancelled.
Yes, sir.
From there, here you will get r cube. So P axial, you will get 2kpr divided by 2kp divided by r cube. 2kp divided by r cube. So this is the formula that you should learn. This is the important formula.
Okay, sir.
And this A is very smaller than R. This is a condition for the short dipole. Short dipole, or you can say that ideal dipole.
Okay, sir.
Means if you have a dipole and that dipole is short dipole, means the distance between the dipole to charge of the dipoles is very small as compared to the R. Then then we can neglect A in comparison to R, and we will get this formula.
Yes, sir.
So from here you know that this 2 is constant, this k is constant, and this dipole moment is constant. Uh, and this is here, then there will be no r because we have already considered the r, so we can remove r from here. So the formula is 2kp divided by r cube. So we can write this E axial is inversely proportional to 1 by r cube. This is the, just note it down.
So this equation is for what? The one in blue.
This na, this occasion.
No, this one, the one below.
This na.
Yes, sir.
Okay. Actually, this equation shows that the electric field due to the dipole varies inversely as a cube of distance. I have told you
Okay.
that if you are taking a single charge
Yes, sir.
and at this point if you want to find the electric field, then electric field will be like this.
Yes, sir.
Yeah. R square means Here, if you will increase the distance, the electric field will decrease much faster than this. This means
Okay,
that,
sir. Okay.
yeah, means in case of dipole, uh, that if the distance from the dipole of the point increases, okay, then the electric field will decreases uh, faster than the electric field due to a single charge. This is the meaning of this,
Okay, sir.
and we can draw the graph also. Okay, so
Okay.
no need of this. Just remember this. It will be fine.
Okay, sir.
Have you written this? You just write this. This is a single charge only,
Yes, sir.
and in dipole we have two charges. Single charge. So due to single charge, electric field is like this. This sign is known as the proportionality sign. Like potential in Ohm's law, uh, potential difference is directly proportional to current. So
Yes, sir.
like this electric field is inversely proportional to
Okay, sir. Finish, sir.
distance. So next topic is, write the heading, electric field on the equatorial line of electric dipole. On the equatorial line of electric dipole. So I have told you what is the equatorial line. Suppose we have a dipole like this, and here a positive charge. This is the dipole, and this is the center of the dipole. And suppose if this distance is A, this distance is A. We want to calculate the electric field at this point. This is the equatorial point. Equatorial line, you can say this is the equatorial line.
Yes, sir.
And this is also the perpendicular bisector. This line is the perpendicular bisector, means this line bisect this line. Means in bisecting means dividing the line into two equal distances.
Yes,
So
sir.
that is, I am supposing this point as O and this point as P. This point as P. So we want to calculate the electric field at this point. So for that we have to do some construction. We have to do some construction. Just first, what we will do, we will just calculate the electric field due to this charge at 1, and after that we will calculate the electric field due to this charge at 2. Means this is the position 1, this is the position 2.
Yes, sir.
So first I am just calculating the electric field at this point due to this minus q charge. Means finding the direction. So
Okay.
first join this point with this point P, and this, as this is a negative charge and this is a negative charge, the direction of electric field will be in this direction.
Yes, sir.
This will be E1. Now join this. Very simply you will get the answer.
Okay, sir.
Now see this. So this is the positive charge, and at this point, due to this positive charge, direction is in this direction. This is E2.
Yes, sir.
And okay, now this thing is clear. Now I am just supposing this angle as theta. I am supposing this angle as theta, and this is the symmetrical figure, so I can say this angle is also theta.
Yes, sir.
What I am doing, we have the electric field, one electric field in this direction and one electric field in this direction.
Yes, sir.
So we have to calculate the resultant electric field at this point P. So for that we will add this electric field E1 and E2 vectorically.
Okay, sir.
Yeah. Vectorically we will add. So this is E2. So what we should do now?
E2 minus E1?
No, that we can do in case of two electric field vectors when they have the 180-degree angle.
Okay.
This time the angle between the electric field is not the 180-degree. We even do not know the angle. What is that?
Yes, sir.
So actually there is a one technique that I will use here. Okay. I am just drawing a line which is parallel to this line. This
Okay.
line is parallel. This line means this line and this line is parallel. And we know that one property in ninth class is this line and this line is parallel. So this angle, if this angle is theta, then this angle will also be theta.
Yes, sir.
And with the help of symmetry, uh, you can say this angle will also be theta. Not by the symmetry. If you don't want to use symmetry, then you can say this is the line, na? This is the line, and this line and this line is parallel. If this angle is theta, then this angle is also.
Theta.
So here we are using a little bit of geometry. So now what we will do, we will take the component. I have told you the resolution of vector in this chapter also. So we will resolve this E1 and E2 along x-axis and along y-axis. And in this direction means this horizontal, this is x-axis, and this vertical line is y-axis. So just we will do the now see here. See here. This is E2. Now I am taking a component. The component of this E2 in this direction is E2 cos theta.
Yes, sir.
And in this direction, when you will take the component of E2 will be E2 sin
And
theta.
theta.
Similar thing we will do for E1. In this direction, E1,
E1 cos theta.
and this vector is in this direction, so we will take the
E1.
E1 sin theta.
E1 sin theta.
E1 sin theta. Now this thing is clear. The direction thing is clear.
Yes, sir.
Now the magnitude thing. Now the magnitude. So this distance I have supposed as A, and this distance I am taking this distance as R. R is the distance between OP. So this is a point P na.
Yes, sir.
So OP is equal to R. And this O, and I am just, and this is a triangle na. This is a triangle. Suppose
Yes.
this is a triangle OP and A. So OA is, can you tell me what is OA? OA.
OA.
OA is small a. This OA distance is a small a. Okay.
Okay, sir.
Fine. So we have a triangle. I am just making the triangle here. This is point P, this is point O, this is point A, and this distance is A, this angle is theta, this distance is R. So we will have this. When we will apply the Pythagoras theorem, we will get this A square plus R square, means R square plus A square. Pythagoras theorem. So means we have this distance A square means R square plus A square, and this distance also we have R square plus A square.
Yes.
So if I want to calculate electric field E1, so I will write K Q and the distance between this point 1, or you can say 1 and this point P, what is the distance? This distance na?
Yes, sir.
R square plus A square means under root of R square plus A square and whole square of this. So if you will calculate E2, then you will get KQ divided by R square plus A
E square
square to the power means under root of this and
whole square.
KQ divided by under root of R square plus A square and square of this.
Yes, sir.
So now see E1 is equal to E2. We have E1 and E2 are equal.
Yes, sir.
E1 and E2 are equal here. So in Y direction, both the electric field will be cancelled out. This electric field will cancel this electric field because these two are in opposite direction.
Yes, sir.
So in Y direction, electric field due to both the charges will cancel out. Electric field due to both the charges cancel out. So in X direction, we have net electric field in X direction. Ex is equal to, we will add this two electric field, E1 cos theta plus E2 cos theta, because they are in same direction.
Yes, sir.
So I can write E1 cos theta plus E2 cos theta, and here I can write E1 is equal to E2, both are equal and I am supposing this as E. So instead of E1 I am writing E cos theta, here I am writing E cos theta. So this will become 2E cos theta. This will become 2E cos theta. So net electric field in X direction is this, and net electric field in Y direction is 0. Okay. So
Okay,
if
sir.
we want to calculate the net electric field at point P, then we will add both the electric field in both the direction. So if you want to calculate net electric field at point P, so this will be the net electric field at point P vector. You will add electric field in X direction plus electric field in Y direction. And electric field in Y direction is 0. So net electric field at point P is only Ex. Ex. Okay. So in terms of magnitude, if you want to write, then you can write, then you can remove this arrow. E net at point P is equal to Ex. And what is Ex? 2E cos theta.
Yes, sir.
And 2, what is the value of E? E is this. E is this na? KQ divided by R square plus A square to the power 2. Means under root of this and square of this. We will get uh, just a minute, just wait. We can make it more easy. So this is even now. So this will become r square plus a square, because when you will do under root of square, then it will become this. So E2 you will get KQ divided by r square plus a square. So you can write E is equal to E1 equal to E2 is equal to KQ divided by r square plus a square. So the value of E we have KQ divided by r square a square.
Yes, sir.
So now no need of this. When you are driving something, try to make the things easy as much as possible. So the value of E
Okay.
is KQ divided by 2E. Now I am putting the value of E, KQ divided by r square plus a square. Now we will find the value of cos theta. Now we will find the value of cos theta from here. From here we can find cos theta is base divided by hypotenuse.
Yes.
Opposite to this angle, this is perpendicular. This will be base and this will be hypotenuse. So now tell me the value of this base divided by hypotenuse. Ziyad, what is base here in this triangle?
A, right?
Yeah. And what is hypotenuse?
R square plus the root of r square plus a square.
Yeah. So we will put the value of cos theta here.
Yes.
Cos theta, instead of cos theta, we will write a divided by root of.
R square plus a square.
So the final answer you will get after calculating all this, k, I'm just separating it q into 2a. I can write this above thing, and this will become r square plus a square to the power 3y.
Yes.
This is why this is becoming 3y2, because this is r square plus a square now,
Yes, sir.
and this can be written as r square plus a square to the power half.
Yes, sir.
So this power 1 we will add power.
Yes.
So the power will become 3y2.
3y2.
So we can. In this way, I have written that.
Okay, sir.
So we know that q into 2a is equal to p.
Yes.
P is equal to q into 2a. So just write here kp divided by r square plus a square to the power 3/2. This is the net electric field at point P, and this is also known as electric field at the equatorial point. Equatorial. And this is also known as electric field at the perpendicular at a point, or at a point which is when we draw a line from that point, that is the perpendicular bisector. Means you can say electric field on the perpendicular bisector.
Okay, sir.
You can also write this as perpendicular. So this is the thing. And one thing more I want to add here. We already know that this distance A is very much smaller than r. So we can write r square plus a square approximately equal to r square. So we can change in this formula. E equatorial, I can write kp divided by, instead of r square plus a square, I will write r square to the power 3 divided by 2, and this will become just power 2, and power 2 will cancel out from here. So you will write E equatorial is equal to Kp by R cube. So this is the formula that you should learn. Equatorial point. And earlier we have got E axial. What we have got? E axial 2 Kp by R cube. So from here also we can say that one thing, E axial is equal to 2 times of E equatorial. When you will compare this equation and this equation, then you will get this. And what about the direction? What about the direction of this? When you will talk about the direction, then direction, sorry, direction of electric field, direction of E equatorial. Now, see here, this electric field, this cancel out, means the direction of electric field will be in this direction, means E equatorial is in this direction, and direction of dipole moment is in this direction.
Yes,
So
sir.
means direction of this electric field and the dipole moment in this case are opposite.
Yes, sir.
So this can be asked in the examination, means in case of the means tell the direction of electric field with respect to the electric dipole in case of equatorial line of electric dipole. When you will calculate the electric field on the equatorial line of electric dipole, means if the direction of electric field at the equatorial point is opposite to that of dipole. So I am writing here. So that direction of E equatorial means opposite to the direction of this short form is okay na? Short form of direction.
Yes, sir.
Opposite to the direction of electric dipole moment, or you can say electric dipole. So the direction of electric field is from this time positive to negative charge. That is from positive to negative charge. Earlier, the direction of electric field is from negative to positive charge in case of axial point.
Yes, sir.
So just note it down. I'm just zooming it out a little bit so as to cover more area. Is it fine now? You can note it down easily now. This figure is looking little bit complex, but when you will solve this, this will become easy for you.
Yes, sir.
I can zoom it. Can we zoom it now? No problem.
It's okay.
Try to make the figure properly,
Okay.
because there are lots of things. This is the theta. There is a theta, there is a r, and I am writing here this r is a distance. Small r is a distance between center of dipole and equatorial point. Equatorial point. And a is the We already know A. Theta is the angle between the dipole and the this is the theta, and nothing else. In horizontal direction, we are considering x axis. In vertical direction, we are considering y axis. Should I scroll down?
Yes, sir.
So this is the derivation, and derivation about the derivation, I want to say that uh, practice is very important, because definition you can easily write. You can learn easily what is electric field, the space or a region around a charge in which another charge experiences a force. Students seems the definition part or the theory part easy, but when it comes to the derivation, in derivation mostly you will see there will be the use of maths.
Yes, sir.
We have to do the calculations and all that. And you will get the derivations in your examination also. So from that perspective, you should practice the derivation also. Written, yeah.
Yes, sir.
Sir, you can ask me when you have
Yes.
completed. Because we have a limited time. So when completed, you can. Yeah.
Okay, sir.
And from starting to here means if you want to ask anything, if you have a doubt in the calculation part, in the direction part, in the formula, and in the diagram that I have drawn, then you can ask me. You are
Okay,
if
sir.
you are giving me any suggestion that this electric field should not be from here to here, this should be from here to here, then you can also ask.
Finish, sir.
Very good. So our next topic is the electric field on the general point of electric dipole. So write the heading, uh, electric field on the general point of dipole. So general point of dipole means I have told you if you have a dipole, if you have a dipole, this minus q charge plus q charge, and this is the center of dipole. And if this distance is a, this distance is a. And general point means a point which is not on this axial line, not on the equatorial line. This line, na, this line of dipole is known as the equatorial line. Which line? Equatorial
Equatorial
line.
line.
Equatorial line. And this whole line, this is from this line is known as the axial line. And earlier, what we have done, we have just calculated the electric field at a point on the equatorial line. And also we have
Yes, sir.
calculated the electric field at a point on the axial line, which is this is just the center of the dipole. This is O, center of the dipole. Now we will calculate that electric field at any point here. So I am supposing point here, and this point is at a distance of r from the center of dipole. r from the center of dipole, and this makes an angle theta. This dipole makes an uh, means this line makes an angle theta with the dipole. Okay,
Okay, sir.
so and you want to calculate the electric field at this point. G is the general point. So just I will write the formula only. Just I will write the formula. So the value of electric field on any general point is equal to constant K, P is dipole moment, R cube, and under root of 3 cos square theta plus 1. This is enough for you. Derivation is not. So you can just know the formula. You should know the formula. What is the formula? What is theta? What is
Okay.
R? What is K? K is constant, na? K is constant. 1 upon
Yes,
4
sir.
pi epsilon 0
Yes,
or
sir.
epsilon naught. P is the dipole moment. P is the dipole moment. Q into 2A. R is the distance. Okay. So R is the distance. So this is just, you can say, the general formula of electric field due to dipole. This is the general formula of electric field. This is also the general formula. Why I am saying this is general formula? Because if you know this formula, then you can calculate the electric field at this point P and at this point Q. So let's see.
Yes, sir.
With the help of this formula, if I want to calculate number one, electric field at the axial position, electric field at the axial position. So at the axial position, what is this theta? If this G comes to this P,
Yes,
what is
sir.
the theta? What is the theta? If okay, just listen. Just listen. Uh, See here now.
Yes.
This is the plane, and
Yes.
okay, this time there is some theta between this plane and this pen.
Yes, sir.
You can consider this pen as a line.
Yes, sir.
So now this is the general point. This is a general point, and here somewhere will be the axial point.
Exactly.
So now this point is like this. So what is
Yes,
the
sir.
angle this time?
0.
Very good, very good. And one thing more we will clear here. Suppose this is the general point and this is the plane. Now at the equatorial point, what is the angle between this
90.
and this? Very good, yeah.
90.
So for axial, if I want to calculate, so I will put the value of theta is equal to 0 degree. So now if we will put theta here 0 degree, then we will get Kp divided by Rq, and cos 0 is
90.
no.
No.
Cos 0 degree is 1.
Oh, yes, sir. Yeah.
So when you will multiply 3 into 1, this will become 4, and you will take the root of 4 as 2. So we got this.
Yes, sir.
If we want to calculate at equatorial point, then we will take theta is equal to 90 degree, and cos 90 is equal to 0.
Yes.
So we will put 0 here. 3 into 0 is also 0,
Yes,
and
sir.
under root of 1 is 1. Then you will get this Kp divided by R. So we have derived this, and we can just derive this thing from this just general formula, from this general formula. Okay, that is fine. Okay, just note it down, and after that we will have next topic.
So can you scroll down? Finish it.
Very good. Now next thing is the electric field line. Write the heading electric field line. So the we have discussed the electric field,
Yes.
and the electric field is a space around a charge in which when another charge enters in that field, that charge experiences the force. Means due to
Yes.
the field, a charge experiences a force. Now, can we see the electric field? Means
No.
this pen,
Yes, sir.
if this pen have a charge, suppose, just imagine. If you have a charge, can you see the electric field?
No, sir.
We cannot see the electric. Can you see the force? No.
No, sir.
We cannot see the electric field, but what happens? What happens? We want to make the things easier. Actually, we want to just show the electric field, okay, from a source charge. Means suppose if you have a charge plus q, and if you are calculating the electric field at this point, and now you are moving, you are calculating electric field at this point too. So obviously we know that E1 is greater than E2,
Yes,
but
sir.
we cannot visualize this. For visualizing this, all the things, there is a concept electric field line introduced, and this is just the imaginary concept. I am just writing the definition only. Properties we will discuss in the next class.
Okay, sir.
So electric field lines are the geometrical representation, geometrical and pictorial. We will get the picture of electric field.
Yes, sir.
Geometrical and pictorial representation of electric field. This concepts is given. These concepts are given by some scientists, so as to get the feel of electric field better. Geometrical and the pictorial representation of electric field. And in the next class, we will discuss the properties of electric field. Electric field lines. And sometimes this electric field lines is also known as lines of electric force.
Okay, sir.
Just wait. Lines of Ziyad. Just write it down, and I think this is enough for you.
Okay, sir.
And have you got all the point now? We have discussed the topics today. We have discussed.
Yes, sir.
We have discussed the electric dipole. We have discussed electric field, this, and this, and in the next class we will discuss this.
Okay,
Okay?
sir.
Slowly we are moving. This is the last topic.
All right, sir.
And one thing more, Ziyad, I will give you the assignment, okay, on the basis of this topic,
Okay, sir.
and I hope that you will solve that assignment.
Yes, sir.
Electric field lines. Okay, Ziyad. So we have 1 more minute. Just if you want, then you can be.
Okay, thank you, sir.
Okay, Ziyad. And if you are getting any problem in studying and in getting the concepts, then you can ask me.
Okay, sir. Thank you, sir.
Fine. Thank you. Hello, Sarah.
Hello.
How are you?
Good, Alhamdulillah.
How your studies are going these days?
Tomorrow my school is opening, so
Tomorrow? Oh,
yeah,
very good. That's fine. So you, I think you will be very happy for that.
I guess.
So in school, what topic is going on?
The light chapter,
Refraction of light or reflection of light?
reflection,
Reflection. And we are discussing here
refraction.
But after this class, we will have one more class. Okay? Because we
But
have.
I'm not today. I'm not free.
Okay, no problem. Then in the next session we will complete that. Okay, fine.
Yes, sir.
And are you getting now this reflection?
Yes, sir.
Are you sure?
Yeah.
So what is the reflection, Sarah?